Why are we doing that triangle?
Huh?
Why don't we do the bottom triangle?
We're doing the area between the two curves. So we could also do this one here. Yes, I'm just looking at it. That would be more correct, I guess you would say. We have to do these two for sure.
Both of them, or like, is that the when we do the equation?
That would give you this one, yes, because it's the area in between the two curves of this one. You would actually, because this one's on top now. I was only actually asking for this area down here, though. I was really only focused on this area. I don't like from here to here. Okay. Now, let's go ahead and go over the actual formula. If I do this with the summation, as we saw before, I'm going to be summing all the rectangles here in between these two, which is going to be f of c sub k minus g of c sub k times delta x. You would do the same thing that we did that Kathleen told us before, the top minus the bottom. However, in this case, this is when we're doing the rectangles. We would just create an infinite number of rectangles in between those two, and using that equation would be able to give me this right here. However, you are very rarely going to use this. Instead, what we're going to do is just use the upper minus lower rule. The upper minus lower states that if I go from A to B and I'm finding the area between two curves, it is going to be f of x minus g of x dx, where this is on top and this is on bottom. Now, for the first equation, I'll just provide you with a brief visual real quick. Let's say we have this graph here. With these two curves, we have this one here. Then we also have this one here. If we create these rectangles here, here, that all have the same x value in between them, well, I know that this right here, this distance is going to be delta x right there. I know that the top up here is going to be f of c sub k. I know that the bottom here is going to be g of c sub k, whatever those points are. And to find out this height, what am I going to do? The top minus the bottom. And that will give me the distance in between those 2 points. So that is the reason that we do f of c sub k minus g of c sub k, all to get our height, this is the height of each rectangle, times delta x, which is the width of each rectangle there. Okay, do we all see how these rectangles work to add together to the area under the curve, and how we can then transform that into this integral that we have, which is nice and easy? Yes? No? Maybe so? Any questions before I move on? I want to make sure we actually understand what's going on here. Catherine?
In the first example, you said you didn't want the little triangle.
On the first one, yes. I just messed up the bounds. This should not be from 0 to 10. It should be from, let's say this is 5 and this is 10. Then this should be 5 to 10, 5 to 10, 5 to 10. Because if we did it that way, then, well, what equation's on top now?
The 5.
The 5. So you'd have to actually have 2 integrals in this case. It would be different. Now, let's go ahead and practice this one. Find the region between y equals cosine x. Oh, sorry, before we move on to that. Any more questions on this section here? No?
So there's no delta x in the upper lower interval?
What do you mean?
In the equation with the
Right here?
Yeah.
No.
Oh, up here? There's the delta x right there.
That's
Yeah.
not in the interval though.
This delta x turns into dx. So that's why whenever we transmit it, it's just a different way of saying dx, because dx just stands for the differential of x, which is x as it approaches very, very close to 0. So it's basically saying we're still multiplying by x, but not really. Caleb, can you close the door on your way back? Now, we want to find the area in between the curve for y equals cosine x and y equals sine x from 0 to pi over 4. Well, 0 to pi over 4, remember pi over 4 for sine and cosine are both equal to each other. So basically this is asking where they intersect. So we're going to go from 0 to right here. So I'm going to go to here, which means I need to go ahead and shade this right there. This is what I'm finding the area of. What we need to determine is what is on top and what is on bottom. Which function is the upper function? Cosine. Cosine is the top, and this is the bottom. Therefore, I'm going to do my area formula as my bounds are 0 to pi over 4, and then we're going to do cosine x minus sine x dx. All right, the integral of this is going to be sine of x minus negative cosine x from 0 to pi over 4.
Wait, why did you say minus the cos?
Because the integral of sine is negative cosine. So with a negative negative, it makes it a positive. Then I'm going to go ahead and input both of these. What is the sine of x plus cosine of x going to be equal to? We get the sine of pi over 4 plus the cosine of pi over 4 minus sine 0 plus cosine 0. Well, the sine of pi over 4 and the cosine of pi over 4 are both equal to what?
45.
Well, that's pi over 4 is 45 degrees. What's the sine of 45 degrees, though?
Wait.
No.
1 over root 3.
So close.
Square root 2.
1 over root 2 or?
Square root 2 over 2.
Root 2 over 2. So this is root 2 over 2 plus root 2 over 2 minus the sine of 0 is 0. What is the cosine of 0? Minus 1. I'll say, yep, minus 1 because you have to distribute the negative there. Sorry, y'all. I have to do this right here. Attendance real quick. Okay. So my answer in the end becomes approximately about 0.414 units squared. Once you do that.
Why is it square?
That's area.
Oh, because we're doing the area. Now, I want you to go ahead and try to do the next one on your own. Graph both of these into your calculator. See which one's on top, which one's on bottom. You are not always going to be allowed to graph these, however, on your calculator. See if you can graph it without a calculator. If you can't, just go ahead and put it on your calculator. So you can find out what's on top, what's on bottom. I will draw it out in just a moment and then let you all do this on your own. Sine of x should be easy for you to graph. Secant squared is a little bit harder, however.
So 1 over
Yep.
squared.
Okay, your graph should look like this. This right here is sine of x. This right here is secant x. We're trying to find the area from approximately here to here, or 0 and pi over 4, with this being 1, but that doesn't really matter. So, there is your equation. This is the top,
So,
this is the
I'm gonna zoom out.
bottom.
Oh, the degree.
Stop doing it. Oh, that's doing that a lot. Okay. I don't know. I just zoomed out. Why does it look like that?
Well,
Do you want to
Can someone tell me, what is the integral I set up now? Let's go with, Ben, what integral am I setting up right now?
Would it be secant squared minus sine x?
Secant squared minus sine squared, so minus sine of x dx from 0 to pi over 4. That is correct. What is the integral or the antiderivative of secant squared, Emma? Tan x. And what is the integral of negative sine?
Positive
Plus cosine of x from 0 to pi over 4. So then, we are going to get, well, the tangent of pi over 4 is 1. If cosine of pi over 4 is root 2 over 2. Then we're going to do minus the tangent of 0. What is the tangent of 0 equal to? 0 plus, and the cosine of pi over 4, so the cosine of 0 is equal to 1. So we get 1 plus root 2 over 2 minus 0 plus 1, which is equal to root 2 over 2 units squared. Or you could say 0.707 units squared as well. Okay, does this make sense? Are there any questions that I can answer about this? Because this process we're going to be doing for the next today, tomorrow. Then you will come back on Monday after spring break, and we will have a little review day about this stuff. I will do your homework checks. I'll make sure that you've all done all the homework that I've assigned. And then Tuesday we will take the quiz. The quiz is only it's very short. It's 3 multiple choice and 1 free response question. Very short quiz. That's just kind of how it's going on as we go along. Yep, Catherine?
So for 10, are we just supposed to memorize what the values are at certain points?
We will have a trivia to go over, but if you can't memorize, can you draw out a 30, 60, 90 and a 45, 45, 90? So draw out the 45, 45, 90. This is 1, 1, and root 2. What is the opposite over adjacent for 45? It's 1. That is what I expect you to be able to do. If you can memorize them, I would memorize them. But if you can't, then that's fine too. Okay, everybody. Your homework. Oh boy. You have 20 minutes to work on.
Wait, is the PC going to be over?
Nothing. Hooray, no homework. Yeah, yeah. No.
Is the PC going to be over what we just learned?
No. Your homework is 1 through 8. 1 through 8. Try to do as many of them without a calculator as possible. Some of them will require a calculator, however. Hey, you have about 10 or so minutes to work on this homework or last week's homework in order to prepare for the proficiency check. Everybody say goodbye to Evie.
Bye.
All right, now, what do you want Isaac to comment down below?
No PC.
No PC.
No PC.
No PC.
On home, no PC.
The PC is just going to be over everything we've learned.
Yes. All right, Isaac, have a wonderful day.